And many thanks to the organizers for giving me the opportunity to speak among so many people who I deeply admire and respect. This is a fantastic event, and I'm very happy to be a part of it. This talk is based on some joint work with Guillermo Badia and Peter Cintula, and in fact extends some work, as I'll mention, done by Peter Hayek towards the end of his life. That was initially joint work with Peter Cintula, and then afterwards Gia and I came in and we sort of kept sort of expanding the project and changing it and producing what I'll present today. So let's begin. So Rosser's undecidability theorem, proved by the senior J. Barclay Rosser, proved the essential undecidability of piano arithmetic in a 1936 paper. To say that the theory is essentially undecidable is that no consistent extension of that theory, in this case PA, is decidable. And it wasn't until Tarski gave a proper definition of that notion. I guess I should pop down here so that I can use the laser. So here's Rosser and here's Tarski a few years before he gave the definition of the notion in question. And after that was done, the next natural steps were to establish similar results for weaker arithmetics, in particular leading to what is now the standard sort of textbook example of not only an undecidable theory, but essentially undecidable theory, which is Q due to Raphael Robinson. And you can see him here next to the famous Julia Robinson. And in joint work then with Tarski, this, or maybe, well, not with, in a book that was jointly co-authored with Tarski, this was further extended to R, which is weaker than Q, and is now very, very widely studied. There's a whole cottage industry of R studies. Unfortunately, not the right kind of R for this audience, but some kind of R or other. So that's sort of the prehistory here. Q and R are very widely known, as, and they can be classically axiomatized as follows. Q, as I said, is the standard textbook presentation of a undecidable arithmetic theory, unless it's piano arithmetic. But if it's not piano arithmetic, then it's Q. So, and R is stated here, and it's very minimal, using this overline notation to pick out numerals, which I'll define properly in a moment. R really just tells you that over numerals, the arithmetic operations are faithful. Identity is faithful, again, just over numerals. The ordering relation is faithful in a sort of particularly sort of constrained way. Note, I've stated this with a biconditional. You'll sometimes see it stated with a single conditional, because in classical logic, the other direction is more or less trivial. And finally, this sort of linearity principle with respect to the ordering. So those are Q and R, again, very well known, widely studied. And the aim of the talk today is to consider variations of these theories and what I'm going to call the Kleene structural argument for essential undecidability. So Rosser's original 1936 argument adapted the same fixed point construction used in Gödel's proofs, the diagonal lemma, and as we all know and have personally experienced, this is a fairly involved argument construction. It involves, if you're doing it the original way, you know, the Chinese remainder theorem or other substantial machinery. And what Kleene did was to provide a simpler and more general argument, which turned on a comparatively simple recursion theoretic argument, where sort of the key recursion theoretic fact was just imported from the beginning, and then essential undecidability was derived just from that. So Kleene gave this nice general, structural argument, and shortly thereafter adapted it to show that Q is not only essentially undecidable in classical logic, but also intuitionistically. And yeah, that was the state of the art as of the middle of the last century. So Since then, there's, following the natural move I suggested on a couple of slides earlier, there's a natural move to weaker logics yet. Intuitionistic logic is still way, way, way too strong, as we all know. And so that development towards the essential undecidability of Q in intuitionistic arithmetic led to, or piano arithmetic interpreted intuitionistically, not necessarily hiding arithmetic. This naturally led to the question in which theories are essentially undecidable in which logics, weaker than classical or intuitionistic logic. And for the purposes of this talk today, Claney's structural argument provides a nice frame for the question, what are the weakest theory and logic combinations that we can give? Because the original argument was for PA and classical logic. The logic was weakened to intuitionistic logic by Claney. The arithmetic theory was weakened to R. So then the question is, what other mutual weakenings are available? Now that's a very broad question with maybe too broad to provide a natural method from the beginning, but this structural argument provides a frame for tackling the question, because this is a very easy argument form to adapt to weaker logics and weaker theories. So the development which leads directly into this work, as I mentioned, is due to Peter Hayek, who in 2007, and in some later paper the next year, proved essential undecidability for a weaker version of Q, what I'll call Q sim, which is a variant on this Q minus, which was introduced by Jagorsicek and shown to be intuitionistically essentially undecidable. Jagorsicek's work was in the early to mid 2000s. I don't know that it was ever published. I think it was just circulated in manuscript form. And when Hayek, who is here indulging in his other favorite activity besides logic, which is organeering, when Hayek obtained this manuscript, he recognized that, in fact, this weaker Q minus, which I'll talk about in a moment, or actually this Q sim, the proof for Q minus in intuitionistic logic could easily be adapted to Q sim with the logical vocabulary interpreted in terms of the basic fuzzy logic BL, which is probably the logic on which Hayek built his considerable reputation. So let's talk a bit about BL. So as of 2007, the state of the art, as far as I know, was this Q sim in BL. But BL, though weaker than intuitionistic logic, is still a very strong logic. So propositional BL can be axiomatized in the language, including conditional, fusion or multiplicative conjunction, and bottom, where the lattice connectives, negation, biconditional, those things can all be defined. Negation in particular can be defined as the intuitionistic way. And in that language, in the extended language, BL has a whole bunch of properties. So it has all of the distributive lattice consequences for the lattice connectives. It has residuation for the arrow with respect to what they in the fuzzy logic tradition is called the strong conjunction or the fusion. And furthermore, this thing is associative, which gives us this B principle. It's commutative, which gives us the C principle. It actually is stronger than the lattice conjunction. So in this setting, it earns the name strong conjunction, which gives us the bad guy, and the bad guy's near relative. And furthermore, since we have bottom negation defined in terms of bottom and bottom explosive, we get all of the usual explosive badness and some other negation properties. So this is a huge bunch of properties. And so while BL is weaker than intuitionistic logic, it is still a very strong logic. Not just by having the bad guy, but also these other implication types related to combinatory principles. And anyway, it's very, very powerful. And the natural question is, can the Hayek-style variation on Claney's argument be adapted to logics which don't mess around with all of this extra stuff? So let's, having said a little bit about BL, to further talk about Hayek's result, I need to talk about Q sim. I'll talk at the end about, well, I'll have a little bit more to say about Q sim at the end, but for now, just enough to get on page with Hayek's result, is that Q, as presented earlier, the classical theory, differs from Q sim and also Q minus, Grzegorczyc's system, in that it uses these ternary relations A and M to interpret the graphs of the arithmetic operations rather than using the arithmetic operations explicitly. And furthermore, A and M are not required to be either total, nor are they required to be functional. So the resulting system is, in some sense, substantially weaker than the usual. And as Hayek used it, Q sim has sort of at least these axioms in common, Q8 and Q1 through 3. I introduced Q0, which I'll talk about a bit later as crispness assumed for identity. Hayek, in his original presentation, assumes that, in fact, every identity statement tout court is crisp. Here, I've just cooked it in so that, with respect to that it's just part of the arithmetic theory, the difference is more or less meaningless for our purposes. And note then that the basis axioms for A and M are just the sort of natural translations of the usual. And furthermore, we have to have a slightly more convoluted induction axiom for addition and multiplication. I've split this into two for reasons that I'll discuss towards the end, but basically this is the system this is an equivalent system to the one that Hayek used. So the plan for today is to improve upon Hayek's results in two ways. So I'm going to use the Kleene-style structural argument to prove essential undecidability, but we're going to use it to show the essential undecidability of a weaker arithmetic theory, R sim, which stands to R as Q sim stands to Q. I'll give you the axioms in a moment. And furthermore, when the logical vocabulary is interpreted in a logic L0, which I'll introduce in a moment, which is substantially weaker than BL. So the aim will be to show essential undecidability for any logic theory pair which extends R sim in this L0. And then towards the end, I'll revisit Q sim in order to show that this result does in fact improve upon Hayek's results, and show that Q sim, as stated on the previous slide, actually interprets this R sim theory, a sort of a variation on a standard result, when the logical vocabulary is interpreted in terms of an extension of L0, which I will again introduce later on. But both of these logics are substantially weaker than BL. So we'll get a nice general essential undecidability theorem. And furthermore, we'll show that even though we need a few more principles to get this interpretability result, the resulting logic is still quite a bit weaker than the basic fuzzy logic. All right, so that's the plan. So here is R sim. As I said, it stands to R as Q sim stands to Q, more or less. And so, just like in R, we required the arithmetic operations to be faithful. We require the same thing here, but stated in terms of this ternary relation rather than terms of the arithmetic operation. Similarly, with respect to M, we still require faithfulness for non-identities holding between numerals, and this sort of defining property, let's say, for the ordering, the linearness of the ordering. And then finally, we have to introduce, for annoying technical reason, this one instance of the law of excluded middle with respect to this particular variation of an ordering statement. R6 is a consequence of R in classical logic and also in Hayek's version of BL, since he assumes the law of excluded middle for all identities. So you can obtain from that that R6 also holds in his theory. So while we have to introduce an additional axiom, it's still an additional axiom which would just be a consequence in a sort of natural, stronger theory. Okay, so with that in mind, a little bit of ground clearing to say what exactly is the result that we're going to show. So to say, for our purposes, a logic L is we're going to be identified with a Tarskian consequence relation over the formulae of some language, which is a relation of the following type, obeying the usual principles, reflexivity and cut, and requiring that this be a set. For our purposes, and this is different, this is the sort of unusual bit, we're going to understand by the word theory merely a set of formulas. And we'll say that given a theory T and a logic L, the closure of T with respect to L will actually be the deductive closure. So theories are just going to be sets of sentences, and we'll talk about their consequences with respect to a background logic. And we'll say that T is L consistent if it doesn't prove these two things. And we'll still have bottom of the language, we'll still be defining negation in terms of it, but this is still basically the usual negation consistency definition. And finally, we'll say that with this background, that a theory T is essentially undecidable in L if it is L consistent, and every consistent strengthening of T is undecidable. This consistency requirement is something I'll say a little bit more as we go on, but as stated here, the definition suits the Kleene structural argument, even though it builds in this potentially undesirable element that I'd like to get rid of. So perhaps you can give me some suggestions on. Well, anyway, we'll come to the consistency question right now. This is in place to fit the structural argument, which, as I'll see in a moment, turns on using negation to decide inclusion in a pair of disjoint sets. So we need consistency in order to make this structural argument work, but for our purposes, it's enough if it's just satisfied for formulas in the arithmetic language. Okay. So, first theorem, if L is a logic over a set of formulas form, and you have an extension of that logic, or perhaps an expansion of that logic in an expanded language, such that all sigma 1 formulas, I'll come back to define those in a moment, are all sigma 1 formulas of the smaller language remain sigma 1 formulas of the bigger language. And furthermore, that T is an essentially undecidable theory in L. Then for any theory S of some expansion or extension L prime, which is consistent and which strengthens T, then any such S will be undecidable in the stronger logic. So this just makes precise what I meant by saying we're going to be studying pairs of logics and theories. And the essential undecidability is going to apply to those objects rather than theories tout court. Okay, so let's briefly talk about how the Rosser lemma works, or the Rosser theorem. It relies on this key lemma which imports just this recursion theory fact. So we'll say a theory T enjoys the Rosser lemma in a logic L if for each pair of disjoint recursively enumerable sets of numbers A and B, there is a series of sigma 1 formulas phi n, or one sigma 1 formula phi, as we'll get to later, such that satisfiability of phi n, or its negation in T, decides inclusion of a number in one or the other of the disjoint sets. And then from that, you can obtain the theorem. Let T be an L-consistent theory enjoying the Rosser lemma. Then T is essentially undecidable in L. And that argument is very straightforward. We just import the fact that we have some disjoint recursively enumerable sets where any extension of A, which is disjoint with B, can't be recursive. So in particular, A is not. So then, supposing by the Rosser lemma we have our series of formulas, sigma 1 formulas, then let S be a consistent theory strengthening T, and then just define X to be the set of those indices of formulas that are provable in T. And note, if we have that N is in A by the lemma, we have that T proves phi N. So we have that S proves phi n, and furthermore then that A is a subset of X. And if it's in the other one, B, then the negation is provable, so then the negation is provable in the stronger theory, in which case we still have this disjointness fact because S is required to be consistent. And so we know from this fact that X is not recursive, but is recursively reducible to the set of consequences of S in the background of L. And so then S is not L decidable. Very, very simple schematic argument where the only trick left is to prove that your favorite theory in your favorite logic satisfies the Rosser lemma or enjoys the Rosser lemma. Okay, so let's introduce our weaker logic. Everywhere we're going to be working in a propositional language, including conditional, conjunction, disjunction, and a propositional constant. I'm not going to call it falsum yet, for reasons I'll mention in a moment. And we define negation as before and equivalence as before.
So you're assuming, what do you assume about quantifiers and identity?
I'll get to that after the propositional setup. As a sort of forward, I'm going to settle, well, I'll mention it in a moment. Okay. So this is the basic propositional language, and here is our weaker and somewhat strange logic, L0. And let me just write down, do I? Yeah, maybe. I'll just talk through it. So this is a very strange logic, which has a simple basis in lattice logic given by these 5 basic axioms giving us some lattice properties for conjunction and disjunction when supplemented by these rules giving us sort of the infemality of conjunction and the supremality of disjunction. Furthermore, we have modus ponens and the rule of transitivity. All that's just lattice logic, but we extend it by this rule form of weakening and the rule form of weak permutation. And finally, this rule form of this one direction of one De Morgan equivalence. Otherwise, negation, the properties of negation are just given by the usual instantiation sort of maneuvers. So for instance, we have that negation satisfies the rule form of double negation introduction, given that we have the rule form of weak permutation. And it's immediate from having the rule form of weakening that we have the rule form of adjunction as well. So this is a very strange little logic. On the one hand, it's pretty weak in terms of just extending lattice logic, not even distributive lattice logic or B. But on the other hand, we have these somewhat bizarre ad hoc looking rules thrown in. As I said here, so we have lattice logic, and that is just dictated by the need to use lattice properties of these things. Basically, every part of L0 is there just because we need it in some version of the proof. So we need lattice properties, as I'll gesture at. And the additional principles are needed for specific inferences that we're going to use in proving the Rosser lemma for our sim. So L0 is an extremely artificial logic because we worked our way back to it, which is why it's strange. But while it is irrelevant, it is a subsystem of many well-known logics, including BL, and in fact, it's substantially weaker than BL. Note, I did not include on the previous slide that this propositional constant in terms of which negation is defined is actually bottom. So the negation is not required to be explosive, which is maybe nice, although it's counterbalanced by the fact that we do have this consistency requirement in the theories. So the logic itself is paraconsistent as given, but that doesn't actually matter for our purposes because we're still building in consistency in the places we're going to use it. Okay, so the first order expansion in answer to Graham's question is that given either of the two logics we talk about, we're just going to be defining that in terms of the same way. So we're going to be adding the quantifiers and the identity, satisfying sort of relatively minimal versions of the usual quantifier principles, so universal instantiation and universal generalization. I should note, the usual form of universal generalization in which this antecedent chi arrow doesn't appear is provable in this system. And similarly with the existential quantifier. And then for the identity, we just require that it be an equivalence relation with congruence with respect to formulas and terms. So a relatively minimal first order extension given for any propositional logic we care about. And this sort of speaks to the title of the talk, which is how much propositional logic suffices. Because we're setting this first order expansion from the beginning, what we care about is what propositional inference machinery is needed in order to generate the result. So as I mentioned, we have that this generalization, the usual universal generalization is derivable. In addition to this somewhat funny looking, well, not funny looking, perfectly standard version of an identity principle, which is the rule that from phi t we get that if x is equal to t, then phi t. And that
Phi x. In the consequence. No.
Oh, yeah, right. Thank you. Whiteboard blindness. Right. And it's pretty easy to see why this is derivable. And it just happens to be a useful instance of a version of these as we go. Okay, so with that language, we then extend to an arithmetical language for QL0 over the set of formulas for QSIM. This should say RSIM, but both theories share the same language, in which we have a name constant picking out 0, a function symbol for a successor, or the ordering and the identity, and then these two predicate symbols that I introduced earlier. We'll define the numeral n as is usual. And now, actually stating the definitions properly, we'll say that sigma 1 formulas are those of the form there exists x psi, where psi is some delta 0 formula, which is to say some formula in the arithmetic language where any occurrence of a quantifier is bounded. And we'll define the bounds in this sort of classical way, rather than using the conditional for reasons that will come up when we get to the Rosser lemma in a moment. Usually in some similar non-classical settings like this, one would use the conditional or say the multiplicative conjunction in order to find these, but one, we don't have multiplicative conjunction in the language, and two, we can get away with this classical version for a reason that will come up now. Not quite yet, but that will come up in a moment. So by this n, which I've already used in the meta language, but no confusion should arise, we'll denote the standard that is classical model of the natural numbers in the arithmetic language just defined. That is to say, n will interpret 0 as 0, the successor as actual successor, the order as the proper order, and finally these ternary relational versions of the arithmetic operators to match the graphs of the arguments. And in this model n, we will also interpret the logical vocabulary as their classical counterparts. So negation in n will be classical negation. The arrow in n will be material implication, and so on. Okay. So then we have these two key results. Soundness is immediate, and sigma 1 completeness, which is maybe slightly less immediate, where given some sigma 1 formula and some, this should be the boldface n numbers or numerals, we have that this formula is true or satisfied in n, just in case it's provable in the theory. And the completeness lemma is established by an induction on formulas and basically goes through the fact that we interpret the vocabulary classically in n. Parts of L0 that we need for this, besides the lattice properties, are this guy, aux, double negation introduction rule and the De Morgan rule, remember the one particular direction of De Morgan. Doesn't matter which direction, but it's intuitionistically acceptable. We need those for the care and feeding of negations and bounded quantification statements, again, since we use the classical definitions of those. Okay, so given that the formulas are interpreted classically in N, this sigma 1 completeness result really is restricted to the classical readings of those sigma 1 formulas, but that turns out to be enough for our purposes. So we can show, in particular, the Ross lemma for R sim and QL0, which we stated already. And I'll briefly sketch the proof to see where, roughly speaking, we're using the additional principles beyond lattice logic. So we have assumed we know that A and B are definable using sigma 1 formulas using these usual arithmetic operations, but it's pretty easy to see and more or less just tedious to show that for any delta 0 formula, we can find an equivalent delta 0 formula using this relational formulation. So supposing we have alpha and beta as delta 0 formulas given to us by the sigma 1 completeness, then we can define up the formula we actually care about that will decide inclusion in N and A in the theory. And we can define it in this sort of funny classical looking way where we just use the material implication version to say that if, say, X is not, it's not the case that if X is not a proof of V, then there exists some smaller thing, which is it would, sorry, I got the order wrong there. If V is not a proof of X, then it doesn't follow that there's some smaller thing that is a proof of it. And furthermore, we show phi of X that there exists some V such that psi holds of that, and that this phi of X has our desired properties. The intuitive reading of this formula doesn't matter so much so long as we get that they decide membership in the desired way. That if N is in A, then our sim will prove phi of N is an immediate consequence of sigma 1 completeness. It's just an instance of sigma 1 completeness. The tricky part is if N is in B, when we want to show that our sim satisfies not phi of N. And this is more involved because not phi, this propositional function, is not itself sigma 1. So supposing that N is in B, we know that the natural numbers will satisfy the appropriate formula for some M, and that N will satisfy the negation of alpha for any K. That's just the definition that we've got. So sigma 1 completeness does entail that our sim gives us beta, N, and M from the fact that the natural numbers satisfy that, because beta by itself is assumed to be delta 0. And furthermore, the same thing for the negation of alpha. And using that, we can show that so long as V is less than M, then it's not the case that alpha holds of N and V. And if M is less than V, then there does have to be some U which satisfies B, which, conjoining those two things and using some, I guess I don't list it here, but using some using the De Morgan rule in particular, we can obtain the desired psi. And then using some lattice logic and these other things, we get not psi. And then we can, from that, obtain that not phi of X holds just by quantifying over V. So that gives us that if N is in B, then not phi of N is true. So we just need to show 1 and 2, and basically 1 follows from this, and R4, which recall is the principle telling you that if X is less than N, then it's got to be equal to one of those numerals less than N. And 2 is the place where we need to use the rule form of K, because we've already got beta holding of N and M, so we can get this existential quantifier statement out of that. So then it's not obvious how else to obtain the desired formula without just weakening that antecedent. So this is where the bad guy comes in. Note, so this is where RK is used. RCI is used both here in the Rosser lemma and also, I don't know if I flagged it, but in the sigma 1 completeness lemma. And furthermore, this RCI, which is the rule form of weak permutation, is used to derive both the rule form of double negation introduction and this principle. So those are the three additional things beyond lattice logic. The lattice logic is just used to make sure that the interpretations of conjunction and disjunction do what they're supposed to do. And these additional principles are just shoehorned in to get us where we want to get in the middle of the proof. So then we get the result. R sim is essentially undecidable in QL0. And so whenever you have a propositional logic extending L0, and then a first order expansion of that, and a theory T extending R sim in the expanded first order logic. And furthermore, the combination of the theory and the logic is consistent according to the logic, then we get the essential undecidability. So this is the general result available here. As far as I can, it's not obvious to me how to weaken the logic or the theory beyond what we have. Certainly not the theory, but, well, maybe less so the theory, but certainly not the logic unless there's some trick available to define a psi in some cleverer way than we've figured out to do. So we get this result, which encompasses, for instance, easily available proofs that, for instance, R is essentially undecidable in intuitionistic logic or classical logic or anything in between. So, what time am I at? When did I start? 4:20? Okay. Okay. Well, I'll say a little bit more, but what's left is basically just cleaning house and showing that we do actually generalize Hayek's result. Hayek wasn't working in R sim, and it's maybe not immediately obvious that the system that he proved to be essentially undecidable actually interprets our system, and hence we just need to do a little bit of work just to show that that's the case. But in order to do that, in order to get that Q sim interprets R sim, we need slightly more, just for the reason that, as you'll recall, the Q sim axioms have a bit more structure than the R sim axioms. We can more or less get away with working with very sort of low degree formulas, that is, with very few instances of the implication when proving the essential undecidability of R. But with Q, the axioms of Q involve much more in the way of, where is it? Here it is. In the way of sort of complex nestings of formulas, in particular sort of nestings of conditionals. So we need a little bit more in order to extend, in order to show that R extends Q. So what we work in is SLW, which is a language fragment of a relatively well-known logic, the non-distributive, non-associative Lambek calculus, with weakening and what is now genuine bottom. So this logic, again, extends not lattice logic, but a fragment of the logic B, the basic logic of the Retli-Meyer semantics, given by the positive fragment of which is given by these first group of 5 axioms and these 2 rules. This R-tone rule is often called the affixing rule and encompasses prefixing and suffixing rules. And in addition to that, we still need the rule form of weak permutation, again, basically to make negation work. And now, unfortunately, it's not enough to get the bad guy's shadow. We actually have to have the bad guy himself, basically for annoying technical reasons in that we can't see how the proof goes without assuming this. So this is SLW. And again, this is less artificial than L0. It's closer to logics that people actually care about and has a bunch of nice properties such as rule contraposition, which you may not have noticed L0 doesn't have. It has the sort of intuitionistic complement of De Morgan principles, and again, reductio. And interestingly, we have exportation with respect to conjunction, given that we've got the bad guy. And furthermore, when you assume that some formula satisfies the law of excluded middle, we get the other direction of residuation of the arrow with respect to lattice conjunction. So I'll come back to that in a moment. So we have a lot of additional principles beyond what L0 had. This is a much more natural sub-intuitionistic logic. But it should be noted that this is still weaker than BL because this B axiom, this prefixing axiom, is still not derivable in SL0, which a nice matrix will show you. And so this system is still strictly weaker than the basic fuzzy logic that Hayek used. So SLW, as I mentioned, can be seen as an extension of the positive fragment. Sorry, I misspoke last time. The positive fragment minus distribution of the basic relevant logic B. That's important. With the addition of the thinning axiom, not the CII rule, but the CI rule, typo, and negation defined in terms of bottom, which is just restating what I said earlier. So now, just to clean house and show that we do actually we strengthen Hayek's result, we'll say that a formula phi is crisp in a theory if that theory proves the law of excluded middle for that formula. And then we get the nice result that whenever you have a crisp formula in T, then T actually gets you both rule forms of both importation and exportation of the arrow with respect to conjunction, or that the arrow residuates conjunction. And furthermore, some nice facts this fact that we use once but is worth noting, that if phi and psi are both crisp, then so is their disjunction. That's just given to you by De Morgan. Well, De Morgan and a little bit more, but not much more. Okay, so then we can show that we strengthen Hayek's result, namely that Q sim, strengthens is not the word I meant there, but interprets R sim in the quantified extension of SLW. And the proof is a tedious axiomatic argument using everything that we threw into SLW. Well, we have this little lemma that winds up being useful, but that's not worth dwelling on. Basically, this is just to say that the additional stuff that we added does seem to be needed. The added to L0 to get SLW does seem to be needed in order to prove the R axioms. So K, for instance, is needed in order to show the linearity property of the ordering. Having a genuine bottom and hence an explosive negation seems to be needed in order to show that in Q sim, the negation of an identity is provable whenever, between numerals, whenever the numbers they pick out are not identical, and so on. Besides these things, again, still most of what we need is something like first-order lattice logic modulo some changes. And so we get Q sim is essentially indecidable in QSL, which, as I mentioned, does strengthen Hayek's result. I didn't say this explicitly, but it's worth noting that not only does SLW, the propositional fragment, is that weaker than the basic fuzzy logic, but the quantifier and identity axioms we add to that propositional logic to get a first-order logic are less than what is usually available in first-order BL. So this really is a strengthening of Hayek's result. Let me say briefly one thing, which again is just a little bit of housekeeping. The system that I showed you as Q sim, namely this, is not the system Hayek initially used. As I mentioned, he didn't have as an axiom of the theory that identities are crisp. He just assumed crispness of identity in the logic. But more substantially, he stated the induction principles for addition and multiplication using the multiplicative rather than the lattice conjunction. We didn't even include fusion in the language, so this presentation was not an option. And furthermore, well, I'm not going to say the furthermore. This is the system that Hayek gave. And the system that we gave, I'll just say a little bit to justify why it is in fact equivalent in Hayek's logic and in our logic to Hayek's original presentation. So note we drop phi. But in the case, so then we state Q5 with the lattice conjunction. But to say a little bit to justify why that's not a problem, note we have that identities are assumed to be crisp. And hence, for lattice conjunctions, one of which conjunct is identity, we get the residuation that the fusion would normally give us for the lattice conjunction. So Q5, we can just replace multiplicative with additive conjunction, or lattice conjunction as we have. The same doesn't quite work for Hayek's Q7, because we don't necessarily know that either of these formulas are crisp. So that one we have to do the manual labor of breaking it up into two halves, the second of which is basically just a fusion-free statement of the left to right, or right to left direction of Hayek's axiom. Again, just a tiny bit of house cleaning. In our setting, extended with fusion, Hayek's presentation is equivalent to ours. Hence, same is true in his system. Okay, so I guess there's still a little bit of time left, but I'll wrap up with some final remarks. Just saying, we've shown that our sim is essentially undecidable in QL0, which is this very, very weak, irrelevant logic extended by reasonably minimal first-order axioms. And so what this shows is that the cost of entry for essential undecidability on the logic side of things is fairly low. L0 is weird, but it's weak. So even though the result doesn't extend to relevant logics, which is a shame and kind of embarrassing, we still get it for a wide variety of logics that people care about, and in addition, a wide variety of arithmetic theories that people care about. And another part of this is to show that the structural argument is really eminently generalizable. Maybe not generalizable past what we have, but I'm not willing to place bets on that. If someone can be cleverer than us in cooking up some formula that will distinguish A from B, then, have at. And this both extends, or not extends and strengthens, this strengthens Hayek's results from the previous decade, and I think suggests further avenues of investigation that I gestured at. The natural thing is this really minimal for applying the structural Kleene argument? And a way to put that is in sort of using the terminology of reverse mathematics, is there a reversal available? That is some way of showing that assuming the essential undecidability of the theory in the logic, or assuming the failure of the essential undecidability, can we get that either the logic or the theory has to be weaker than what we have? That would be nice. I don't know. It seems to me that if there's going to be some kind of reverse move available, it'll have to be for this particular argument structure or something similar. Again, just because we need some frame in which to ask the question. Otherwise, there are too many moving parts that can be fiddled in order to potentially get other essential undecidability arguments with weaker assumptions. And I would love it. It would be wonderful if this argument form could be altered to obtain similar kind of results for irrelevant arithmetics, which are much nicer, or for dialethic arithmetics, which are more fun. But I'm not sure whether that can happen, but this is a natural avenue of more work on this area. And yeah, that's all. Thank you.
The question you raise is, can you go weaker?
Mm-hmm.
Okay, good question. I don't have anything much to say about that, but a strategy might be to go very weak and see how strong you can build up until essential undecidability fails. Okay. Now, what we know is that if you go down to LP, then the set of sentences true in the standard model is not essentially undecidable because it has
finite
it has decidable extensions. And if that's true of the set of things true in the standard model, then of course it's true of any subset of that. So you can you can make the set theory as weak as you like. Of course, the cost of doing that is you buy very weak logic without detachment, for example. So at least it's a kind of a bottom level which you might hope to strengthen. I seem to remember that you have an axiomatization for a conditional for LP models. Okay, I've forgotten the details, pardon me, but one thing might be worth thinking about is whether you can sort of push up the failure of conceptual undecidability by adding a conditional of your kind or something similar. That's the thought. As I say, it may go nowhere, but it might be worth thinking about whether you can approach the problem from the bottom up and see whether you can meet somewhere in the middle.
Yeah, thank you. That's really nice. Well, it's very generous of you to refer to the conditional in question as being somehow mine. It is very not. It's introduced by Avron. But I really like the thought. Yeah.
Can you remind me how your logic relates to your L0?
Oh, the one that...
The one you needed to push through the essential undecidability result.
Oh, sorry. For the relation of L0 to which logic?
To LP plus
the right.
Taylor Glunz. Is it? Yeah, it's Glunz.
It's close. I mean, so that conditional is... The implication fragment of that logic is at least intuitionistic implication. It might even be material implication. I'm not sure about that. So the conditional theory is substantially stronger in the LP-based system. But, yeah, the thing that's difficult, I guess maybe the difficulty there, just sort of in finding my way around in the space of possibilities, is that that does have a detachable conditional. So it's not immediately clear to me, exactly the relationship between these logics, but that's a natural question given the good suggestion you made about the method.
And there's also the question of whether you still get a failure, an essential undecidability, once you have a detachable conditional. Again, I don't know the answer to that, but worth thinking about.
Actually, so maybe one way of putting it, in L0, we don't have the rule form of contraposition, but we do have the rule form of modus tollens, namely when phi are psi and not psi are theorems, then so is not phi. And you don't have that in the other logic from my previous work. So that is probably the thing cutting the difference here, but that's a guess that just comes to mind off the bat.
Okay, thanks. I just had a clarificatory question. So the logic that you showed, that was basically relevant logic, except you also had weakening?
Oh, SLW.
SLW. So just the question was, you said you needed weakening there before, because basically you couldn't figure out how to get the proof through or something without it.
Yeah, without it, yeah.
I was just wondering if you could say, I mean, with an eye toward possibly extending the results toward relevance. I mean, what was weakening?
Yeah, so it's...
Say without too much.
Well, it might be easier to address that by pulling up the paper and talking afterwards, because I don't recall the argument off the top of my head, but it's something tedious and irritating. Basically, it's something in order to make one of the induction axioms work. Would there
be a relevant principle that you could use instead to get around?
That would be great. I'd love to know the answer to that. So perhaps later we can sit down if you're interested.
Okay. Yes. Yeah. Earlier in your talk, and I forget which system, Andrew, but you mentioned an interpretation of plus and times, which you mentioned an interpretation of plus and times in terms of the ternary relation instead of the usual operation.
you say more what that was for?
Oh, so that was just to get O systems slightly weaker than Q. So Jagorczyk introduced that variation on Q, basically just to get a slightly stronger essential undecidability result. And we used the same trick to get a slightly stronger essential undecidability result for the system like R. There isn't any sort of more intuitive motivation behind the introduction, just except that we make fewer assumptions about how those relations work.
I naturally thought of the comparison to the four-value logic in, first-degree entailments. That where you have both true and neither true nor false. And it's sort of like the operation being not single valued, but many valued, or being no valued.
Yeah, it'd be interesting if there was some richer connection available. I don't know of any, but it's a nice question, I'm sure.
Very nice paper, thanks.
Oh, thank you.
You mentioned how essential undecidability was sort of limiting in the case of considering the very consistent logic, because it makes a stipulation that the extension be consistent. And so it strikes me that there's a sort of dual version of this, that every incomplete extension is undecidable. Something along those lines. Have you any hunches about what the more appropriate version of this would be for working with dialethic arithmetic? And if so, might it end up being equivalent? Because the Rosser argument seems like it would extend to that type of condition in the same way.
Yeah, I think I share your intuition, but don't have, at least as of now, a good idea of how to sort of get the dual condition you're gesturing at. That would be really nice, and I suspect you're right that there is something there that's available, but I can't say anything enlightening about what it might be as of now. But I would like to know the answer to that question.
Thanks, and awesome talk.
Thank you.
Okay, are there any more questions? Yes?
Sorry,
Sure.
So I don't know if they already asked this, because it's mostly a clarificatory question. Did you find what do RK, RCI, these things that you have to use have in common? Like, did you get like more of a, a hunch of why these were the three ones? Not why each one was required through the proof, but what do they get to? Like, what do they tell us about the logic that makes it fit for, like, more in a philosophical sense?
Yeah, good.
In a logical sense.
Good. So as I said, we came to this logic by a very ad hoc manner of taking the argument form that we knew and removing everything that we possibly could. So we came to this logic from the top down, as it were.
What did you find at the end?
Well, I mean, we found this really strange, highly artificial propositional logic, where, for instance, the rule form of thinning we use just once in obtaining the Rosser lemma, and merely because the particular construction that we used to build the formula deciding membership needed it. And furthermore, the one that I showed you here is the sort of the last in a series of finding weaker and weaker and weaker ones, or by that I mean ones which required fewer and fewer propositional principles in order to drive the result. So unfortunately, the method employed maybe doesn't preclude exactly, but in actual fact has precluded any more intuitive reading of what's going on. For CII, for instance, this CII, RCI, the rule form of weak permutation, that a lot of the uses of that are to drive defining negation in terms of bottom, which is a useful maneuver to make the Kleene argument work. But it may well be that working with a primitive negation, that wouldn't be necessary, which I think would relate to, or potentially give some way into giving a properly paraconsistent or dialethic or version of this construction. But yeah, no, it's a very strange and ad hoc logic that I don't know how to make sense of. Thank you.
Last question, maybe?
I'm just curious. Does Hayek?
Josh, you don't have to speak to this.
We don't even know you're talking right
Then I have to speak to his question.
From the computer.
now. I know.
I'm just curious if
Yeah.
Hayek also tries to add this involutive negation on top of what he's doing.
Oh.
If he does that, then it really gets related to what Mike and Graham are wondering about, because that negation would look more like this FD or LP negation. Just I know it's sort of curious.
No, he doesn't. Because in the fuzzy setting, negation is almost always an arrow bottom kind of thing. Yeah, a lot of the elements of Hayek's argument are artifacts of the choice of the basic fuzzy logic as the system, which I take it that's one of the upshots of our result, is that you can peel away a lot of the fuzziness and still wind up getting the result. No, he doesn't ever introduce involutive negation in this connection. But yeah, absolutely, that is a way into the earlier points.
Also about this consistency notion.
Mhm.
You mentioned that this bottom is needed for this notion to be captured, that you use in this Kleene
Yeah.
right? Is that possible just to replace it by something like a non-triviality or something?
Well, so the reason negation consistency seems to be used is that we're deciding membership. And so, negation does sort of need to behave like a toggle between throwing a number in one set or throwing it in another. And I suspect there's a way of reformulating things so that some non-triviality thing would be available, but
How do you replace maximal consistent by maximal non-trivial or something like this?
Yeah,
So,
yeah.
Just
no, I suspect that's possible, and
I mean, that way we can kick out the bottom and then throw in the stronger negation.
Yeah. Yeah. No, I think that's a good direction, and is a nice convergence point for a lot of the other questions and helpful suggestions you've given me. So, thank you.
Okay, did someone raise? No? Okay, let's thank you.
Thank you.
Good afternoon, everyone. Thank you for staying with us. Let's start with the last presentation of this day. Now we have the talk of Zach Weber, or for the Logicians Liberation League, Cardinal Complication. Well, I shall now give the floor to Zach.
Thank you very much. Do you know how to press start on this? There's a timer. Does anybody know how to turn on the timer? No? All right. Okay. Well, thank you very much. Nice to have you here. Thanks to the organizers. Is Louis here? No. Well, thanks, Louis, for inviting me. It's good to be here and to talk to everybody today. So I thought it would be appropriate to do a somewhat historical talk. So today I'll be talking about Richard Routley/Sylvan's Ultralogic as Universal project 40 years later. Just out of curiosity, who in the audience has heard of Ultralogic as Universal? Right, okay, so I've got the appropriate audience, because that might be everyone in the world. Right, so the Ultralogic it's this essay, the 80-page essay that was circulated in TypeScript around 1977, so that makes it a little older than 40 years. It's the Inconsistent Mathematics Manifesto. When I started my PhD, I arrived to study with Graham Priest. He wasn't around for the first 6 months when I arrived, but so Greg Restall gave me a copy of Ultralogic. He said, "You might like this." And it has meant a tremendous amount to me at various stages. So I'm interested in, both for this event, looking back at it, at Richard Routley Sylvan and his project. So it's a backward-looking, but I hope also forward-looking for the 21st century. It's nice to see the Logicians Liberation League has become a truly international band of pirates who, so here we go. So I will be talking about Richard Routley Sylvan. He was Richard Routley up until the mid-1980s. Then he changed his name to Sylvan. It's very annoying. So I'll be mostly saying Routley because I'm talking about an essay that was written in the 70s under the name Routley. But this is somewhat coming from a forthcoming encyclopedia article, which will refer to him as Richard Routley / Sylvan. That was the best we could come up with as a compromise. He's known for a lot of stuff. In particular, Richard Routley Sylvan, if you Google Richard Sylvan, actually the first thing you run into is environmental ethics. That's what is the most prominent thing. He was one of the important people in deep ecology. He's also known for Meinongian metaphysics and, of course, paraconsistent and relevant logic. And these are not separate projects for Richard Sylvan. They are interconnected in a deep way. They're all part of the same project. And if you wanted to sum it up, I take this from Dominic Hyde's very nice biography of Richard Sylvan. As Sylvan once wrote, "Philosophers fiddle while the world begins to burn." And it was his hope that by working on these topics in an interconnected way, that maybe the world one day could cease to begin to burn. So he's known for proposing and defending highly controversial ideas in all of these areas, inconsistent theories, non-existent objects, non-human value, as Bob Meyer once said in his obituary when he passed away. To get the counter-suggestible Sylvan to defend a view, you just need to remark that the view is utterly discredited. Now that just makes him sound cantankerous, and maybe he was. I did not know Richard Routley Sylvan, but I think there's more to it than that. I think what he saw and what he was urging us to see is that there is value to be found in things that everyone else has left behind. That when the rest of the group has said, there's nothing more to see there, he says, let's look further, and that there is more to see there. He says, a large part of my philosophical life, this is Sylvan in 1996, looking back and also looking forward, has consisted in rehabilitating abandoned philosophical dwellings, habitats, and landscapes that were laid waste or damaged by predecessors who adhered to an entirely defective set of values. So if something, I think, binds all of his work together, it's something like recognizing the value and status of marginalized entities and to recognize their value. Because let's listen to him in Ultralogic. He says, there are whole mathematical cities that have been closed off and partially abandoned because of the outbreak of isolated contradictions. So he sought to make these philosophical landscapes viable, and he sought to do it in this super old-fashioned way that goes back to Socrates and Buddha. He thought that if we just could think better about things, we would live better. Gosh, it's like what Socrates would say if he believed in contradictions and lived in the forest. So it's all connected. So today what I'm going to do, first of all, I'm going to give an argument. I'm going to try to reconstruct the argument in Ultralogic, and I'm going to do it following a genetic progression. So I'm going to go through historically how I think Routley landed on the Ultralogic program. So that's kind of an argument, kind of history. I'll trace it from concerns early on with expressibility, which lead on naturally to a pining for universality, and then thoughts about absolute sufficiency, which leads naturally to inconsistency, and finally paraconsistent mathematics. That's how he gets to Ultralogic 1.0. I'll then try to address whether the Ultralogic 1.0, 40 years on, has it failed? Some people think it has. And if it has, or even if it hasn't, what about an Ultralogic 2.0 for the 21st century? So here we go. So let's go all the way back to his early work. the road to ultralogic and concerns with expressibility. Right from the start, even in the mid-1960s, he is concerned with granting legitimacy to discredited and rejected entities. So he's interested in the existence or lack thereof of objects that seem like they are perfectly good things to reason about. Early on, he's just thinking about, hey, scientists talk about things like frictionless planes. And there are no frictionless planes, but they're really handy to think about. And maybe we should take that seriously. And he starts to be interested in the status of nonsensical sentences that seem like they are essential parts of good reasoning, even if they are nonsensical. So in 1973, Len Goddard and Richard Routley wrote a book called The Logic of Significance and Context. This is a very nice book that is somewhat overlooked. Their concern is with a then, and I think still popular means of dismissing various bits of philosophy, not arguing against, but just dismissing bits of philosophy on the grounds that they are nonsense or non-significant, absurd, meaningless, unintelligible, or just odd, which is an echo of Wittgenstein. It's to say, these things are not even false, they're just senseless. And their concern is to say that that is not a good way of dismissing things. So their claims in that book, early on even, are that there are grammatically correct natural language sentences containing only recognized vocabulary of English that at that point they are calling meaningless. But unlike seriously ungrammatical sentences, these things can figure in valid arguments and can occur as unquoted components of grammatical sentences. So even if these things are meaningless, they're still useful or legitimate in some way. The early Richard Routley, working with Goddard, thinks that these meaningless sentences should be treated as neither true nor false. What a thought. Right, and there's a whole raft of papers. So he's writing this with Goddard. He also writes some papers with Ross Brady at the time about this. He also writes some papers on his own. And they say things like, they're thinking about the deep structure of natural language and languages in which philosophical problems are characteristically formulated. They'll have to be based on some kind of enriched significance logic, which has a third value. So they're already thinking about three-valued logic, and they're thinking of it as nonsense or non-significance, not a classical two-valued logic, which has only truth and falsity. So already at this point, they're thinking, look, there's these sentences. They may be defective in some way, but they should still have a status. They should still be granted some kind of a status and not just rejected, some third value, they're thinking at this point. What are they thinking here? They're thinking of, here's a reconstruction that Goddard and Routley put forward that is kind of a straw man version of a way that a lot of philosophers might try to dismiss various paradoxes. So they say, look, suppose a philosopher reasons like this. Well, look, the premises, so you might be thinking here of something like the liar paradox or the Russell paradox, and your conservative philosopher says, don't worry about that, because look, the premises of an argument lead validly to a meaningless sentence, like the liar sentence. So since it led to meaninglessness, the premises must be meaningless. Well, so therefore the paradox, the argument simply evaporates and the conclusion no longer follows, right? Now we don't have to worry about these things anymore. So I've left it as an exercise for this group. What is self-defeating about an argument like this? Everybody done? Okay, the answer. Right, if it turns out that this argument evaporates, then premise one, that this argument leads validly to meaningless sentences, is no longer true. Premise one says there's a valid argument to a meaningless sentence. If the argument then evaporates, then that's not the case anymore. So this kind of reasoning not only dismisses apparently legitimate objects, but it seems self-undermining in an important way. So even if one were inclined to dismiss such things, perhaps you can't do so without somehow refuting yourself in the very act. So their thought is that apparently defective sentences, they may even be genuinely defective, but they still have to be reckoned with and granted a status rather than, as Hume might have said, consigned to the flames. So at that point, they're thinking, again, that these meaningless sentences could take a middle value. So recently, Hitoshi and Damian, how do you say his surname?
He even mentioned that he used to have a little dash on top of C
you or something? That turned out being a mistake.
Well, none of this is helpful. Okay, so
I don't have any idea how to read this.
so they present what we can recognize.
Sorry.
They reconstruct the argument we can recognize here as a standard 3-value logic where there's a middle value. The important things here, so the end value is middle. What's happening, we're generalizing classical logic. So if you only look at the true and the false, then it's just the truth tables we show our kids. And a sentence it's infectious in the sense that a sentence becomes non-significant if it has a non-significant component. So that's the early Routley working with Goddard. It's transitional work. It prefigures his non-classical preferences, his attention to classically abandoned entities, and grants paradoxical sentences a status. But it's the same sort of status you might just give basically grammatical gibberish. This conservatism begins to fall away around the same time as he's building a house out of stone in the forest. Right? I just live in a regular house. Think about that sometimes. So there's this closely connected little raft of papers between 1975 and 1982, papers and books, and they all tend to cite each other. He says, to see the full argument, see my 1978, you go to that. He says, see my 1982, you go to that. He says, see my 1976. So you kind of goes around, but it circles around basic themes like universality, implication, entailment, and inconsistency. So we'll go from expressibility now to this interest in universality. So his interest in expressing things and saying, look, when you try to say that something is inexpressible, you somehow refute yourself, leads to a desire for a framework that can express everything that can be expressed. Some kind of universal semantics, some kind of formalization of this notion of a language with a deep structure. And in 1977, he produces ultralogic as universal, which both looks to extend the expressive power of classical logic, while at the same time restricting its proving power. So what is a universal logic? I could quote the essay all day. I'll do a little bit. Right? A universal logic, in the intended sense, is one which is applicable in every situation, whether realized or not, possible or not. Thus, a universal logic is like a universal key, which opens, if rightly operated, all locks. It provides a canon for reasoning in every situation, including illogical, inconsistent, and paradoxical ones. Few prevailing logics stand up to such a test. A universal logic should be adequate for mathematical and philosophical purposes, and also for functions in other areas like biology, economics, astrology, theology, and so on. So he doesn't think that these theories even need to be true. I think, apologies to any astrologers in the room. He means logic. Right? He's looking for logic like I tell students, logic, what's great about it is that you don't need to know anything about the world. Logic doesn't care about any accidents. Logic is just about how things work no matter what. So that's what universal logic would be. There are possible misinterpretations of the project. I see various people, when they want to talk about logical pluralism and they want a stand-in for the obvious logical monist, they wheel in this version of Routley. I think he probably is a monist in some sense here, but there are misinterpretations here. He does not say anywhere in this essay that some specific alternative logic is the universal logic. The essay largely centers on a weak relevant logic around DL or DK, which is a little bit stronger than B, a little bit weaker than R. But he doesn't say that that's definitely it. And he doesn't even say that there should be one and only one universal logic. Maybe there's more than one universal logic. And his approach ultimately, like looking these days at all this anti-exceptionalism stuff about logic, his approach is ultimately very pragmatic and cost-benefit oriented. It's not some zealot or true believer He couches all of this in practical analyses from conventional philosophy of science, how we make theory choice. We look at the virtues of the theory, the costs of the theory, and in particular, what can we get from it? So it's not just God spoke to me and told me that relevant logic was the right one. It's if it bears good fruits, then it's good, and if not, then not. So he's after this universal logic and universal language. One objection, and I said this follows on from expressivity, one point that you could raise here, which Ed Mayers does in a recent paper. Oh, so ultralogic has been recently reprinted as a book with a few contributions in it. One of them was by Ed. You can buy it on Amazon for the low price of 900 euros. Right, Ed says, look, you might want a universal language. It doesn't follow from that you get the expressivity requirement. It need not in particular be semantically closed. Compare, say, Tractatus era Wittgenstein. He believes there's something like a universal logical structure, but he thinks that there's things about it that can only be kind of gestured at, and you can't say them. And the Tractatus ultimately ends in kind of self-abnegating mysticism. Routley's project, I want to say, on the other end, is optimistic. I kind of wanted to spell it with a Y. Which is to say, no, we can not only show these things, but say that we're showing them. So this is not a rebuttal to the objection. It's just not the way Routley goes. So the idea is that a universal language can say everything sayable. It also should not validate the invalid. So Routley thinks that that requires restricting classical logic in various ways, and I won't tell this audience at any great length about that. Just in case you need some reminding, there's this thing called the material conditional, and it's a really bad account of the conditional. In particular, it makes all sorts of nonsensical things come out as valid. So an instance of a valid form of the material conditional might be, it's not the case, these are all from Relevant Logic and Their Rivals, Volume 1. It's not the case that if we follow this road, we'll reach the city. Therefore, we shall not reach the city. That just comes out, or the logical form of that comes out as valid using a material conditional. So that's bad. One diagnosis of the problem, why are they bad? Well, they seem to display irrelevance. And Routley did think that, but what I want to point out is that he never thought that the main issue was relevance, or at least in ultralogic and also in Relevant Logic and Their Rivals. He says very explicitly on page 1, our main concern is not relevance at all. Relevance will just be a byproduct of any good implication relation, which should come out in the wash. Our concern is with genuine implication in the sense that amounts to total sufficiency, or as it is equivalently put in the logical case, complete logical dependence with inclusion of logical content. So,
did he think that there was just one conditional or something that expressed this?
I don't know.
Oh.
He thought there was at least one. Yeah. I was thinking during question time, I might get a number of questions that would require me to try to channel Richard Routley Sylvan. I'm not able to do that.
I don't think there's anything about more than one condition in ultralogic. However, at about the same time, he's playing with using a kind of Stormacher construction in relevant logic, where you don't get conditional property expected. He shows sympathy with that. I think that's a book. You've got a paper in that, Mike.
Directions in relevant. Yeah. Directions in relevant logic.
Okay. Thanks. That helps.
Right. Well, so what he's after, whether it be with one conditional or many, is a conditional that captures this notion of absolute sufficiency. So the relation of antecedent to consequent is that of absolute sufficiency. He says again, in ultralogic, the central deducibility relation of ultramodal logic entailment is intended to capture the notion of sufficiency of antecedent to entailment on its own, without any imported truth. That means if A implies B in this absolutely sufficient way, then A really gives you B, and A is all you need for B. If A were the only thing in the universe, you would still have B. And that's what makes it the right kind of implication for a universal logic, because it requires no background information. It's the implication connective that would work even if the rest of the universe disappeared. So if A is sufficient for B, it does not matter what else goes on. Logical laws may go haywire, but nothing subtracts from A's sufficiency, to which he adds that since one is operating with a go any place logical notion, one would expect general success. Sure, this ultra logic is full of stuff like that. Yeah. So another example of a material implication paradox, right? Pick any two random sentences off the internet. One of them implies the other. So what's wrong with that? Well, on this account, I mean, it's irrelevant. What's wrong with it is that P is not necessarily sufficient for Q, nor the other way around. And the way to diagnose this is to say it's not taking enough possibilities into account. In the same way that you might try to diagnose cause and effect by looking at lots of instances, right? If you just look at one instance and you say, oh, you know, I read a book and then the sun set, so maybe reading the book made the sun set. You look at more instances and find out which two things always go together no matter what. So to find out which things are really connected, you have to look which things are always together, which means you have to take more possibilities into account. So this is easily resolved by just taking two possibilities into account, one where you have P without Q and one where you have Q without P, and then neither disjunct is true, assuming that you replace the material conditional, P implies Q, with necessarily P implies Q, and we'll write that now with this symbol, which means ultramodal implication. I think the word ultramodal is cool, and we should bring it back. So you get a failure, not of relevance, but of sufficiency, and you get it because more worlds are considered. So this project of universality calls for more worlds. So if you want absolute sufficiency, you just keep adding worlds. Consider all of them. The more worlds you add, the more they sieve which sufficiency relations persist. So, oh, I don't mean to avoid, right? Yes. If you want to avoid implications, say when Q is just logically necessary, but P is not absolutely sufficient for Q, you have to have various points which are counterexamples to consequence. So in particular, if you don't want arbitrary propositions entailing the law of non-contradiction, then there needs to be worlds where the law of non-contradiction fails in order to get absolute sufficiency up and running. Not because of any particular interest in dialethism or glut theory. That's so at this point, one adds what are now known as non-normal or impossible worlds. So I want to say the concern for universality via absolute sufficiency leads naturally to inconsistent worlds, which makes ultralogics just naturally paraconsistent, naturally relevant, naturally paraconsistent, so they don't validate the spread law that any contradiction entails anything. And you can handle inconsistency without collapse. So that brings us to inconsistency. So how does Routley end up with inconsistency? I've already suggested it, but let's make it explicit by comparing his route to dialethism with another prominent dialethist. So here's, for example, how Priest might argue for dialethism. Graham Priest. So premise one, look, there are some apparently unimpeachable principles about naive proof or about truth or about sets, and they lead via sound arguments to inconsistencies. But there are no good arguments against some true contradictions, and there's no way to deny those unimpeachable premises without at least indirectly contradicting yourself. So more or less, you're deductively forced into the position that there are true contradictions, right? That's a direct kind of argument trying to convince you. So Rowley doesn't argue like that. He argues less overtly, kind of like this. He says, well, look, given this story about universality and expressivity and absolute sufficiency that we have already subscribed to, you're already inclined to suppose that there are worlds at which there are true contradictions, just for absolute sufficiency reasons. And there's no reason
to suppose that the actual world isn't one of those. At least there's no good arguments for the consistency hypothesis, as he and Meyer at the time were calling it. 3, this is an abductive kind of premise. Accepting the true contradictions leads to some very appealing outcomes. The regaining of naive set theory, for example, or a universal semantics, or a universal resolution of the paradoxes. So he points to the benefits. And he says, on balance, we have nothing to lose and everything to gain by going dialectical. So again, if you come away from this with nothing else, I want to emphasize, I think the ultralogic project is at heart optimistic. I think he is worried that the philosophers are fiddling while the world is burning, but that there is hope. The uniform dialectical treatment of the logical and semantical paradoxes to be advanced is not one that you have to adopt if you like relevant logic. It's just a very natural alternative that suggests itself. And it does become a live option for anyone charmed by the semantical analyses of relevant logic. So again, it's this, look, we already have the machinery. Let's see what else we can do. So sooner or later it occurs to you, maybe the actual world is an inconsistent world. It has occurred to me. And he and Meyer at the time were working on a logic called DL, which at the time was for dialectical logic. You can read about that in the Journal of Soviet Studies from 1976. Again, at the time, between 1975 and 1985, or maybe for his whole career, his views are constantly shifting and changing, sometimes even over the course of a book. So Alistair Urquhart points out in a review of RLR1 that early on in the book, it's agnostic about dialethism. It says, maybe there are true contradictions, maybe not, we don't have to take a position. And somewhere around page 200, it says, since arithmetic is inconsistent, blah, blah, blah. So, it's hard to pin down, again, if the question is, what did he think? It's a little hard to pin down, but he's definitely shifting toward this end of things. And if we're looking at the history, late in the 1970s, Graham Priest arrives in Australia. He presents the Logic LP to the 1976 meeting of the Australasian Association of Logic. And at that point, Routley really embraces what comes to be called dialethism and says, the liberating effect of giving up the classical faith is immense. You're free to return to something like the grand simplicity of naive set theory, semantically closed natural languages, having abandoned the towering but ill-constructed and mostly unfinished hierarchies of formal languages, and to intuitive accounts of truth and proof and many other intentional notions.
It might be slightly overstated.
No. No. Does somebody have a watch or a clock or something so I can keep an eye on the time? What, Art? Okay. It's full of overstatements. So if you say somebody has just decided to do their PhD on paraconsistent logic and you give them this and have a look at this, you go, whoa, this sounds great.
Maybe I should repeat that.
Yeah. Well, this is also a cautionary tale. Okay, so, and he puts, right, the title of the essay has a question mark on it. Okay, and he's asked, it's a question. What it does, not so much in terms of payoff, is lays out a program. And the program is to apply recent developments in paraconsistent logic to some long-standing problems to find a unified, universal, dialectical solution. He targets problems from logic, mathematics, language, physics. Right by the end of the essay, he's solving quantum mechanics. And the solution he proposes, again, is this old-fashioned one that we could make progress on serious and real-world problems by thinking better about them. So it's an extended essay on inconsistent mathematics. It's saying how to do set theory and arithmetic and beyond amidst the logical paradoxes with contradictions. What's good about it? It includes actual derivations of actual results. So it gives some axioms and he gives some proofs and see, this is how you do it. It provides an example. It provides a role model of what it would mean to really adopt a paraconsistent logic and really apply it to mathematics without embarrassment as a viable alternative to ZF or piano arithmetic and eventually to other areas of mathematics. So between the lines of the essay, sometimes on the lines, but between the lines of the essay, more than even just the content is this vision and an assurance that, yes, there is this universe of inconsistent sets and inconsistent objects out there, and they're really out there, well, really, in some sense, out there in Ausersein, which I've come to think is not a correct use of Ausersein, but that's all right. They're out there. You just have to be brave enough to look for them. So if nothing else, that's valuable about the essay. It issues a lot of promises. And he says, far more promises than could be achieved in a standard research project lifetime. He repeats and repeats, well, look, this shouldn't be too difficult. All we'll do is jettison some logical junk that wasn't being used anyway because it's just junk. I mean, nobody really uses ex falso quod libet, right? So we should have no problem just reconstructing various theories without it. And he says famously, the strong ultramodal claim is the expectedly brash one. We can do everything you can do, only better, and we can do more. So this is Ultralogic 1.0. And it's got various attractive features, as I've indicated. You can have back, or appears that you can have back full naive comprehension in set theory, and then you can just derive the existence of the Russell set, and that it's contradictory, and that's fine. And you can derive the existence of the Routley set, which is the set of all things that are not members of the Routley set, and that's fine. And it's all very exciting stuff. So even in that paper, he shows that you can prove the standard ZF axioms. You can reconstruct some basic proofs in arithmetic. He sketches a questionable proof for the axiom of choice, points to some other exciting possibilities. I think what's interesting is not so much, it doesn't show so much what we have to learn as how to search for it. And it has inspired, at this point, generations of logicians who number in the single digits. So, but over many generations.
Yeah, but it's quality, Zach.
It's quality, right. Well, you know, if you're out in the forest, it's all right. So with this comes the question that if you're serious about inconsistent mathematics, this question of classical recapture comes up. So you say, well, this sounds good. What about the non-dialethic mathematics? What is the status of that in the eventual presence of an ultralogical rival? And he says, in order to sustain the ultramodal challenge to classical logic, so this is not friendly rival, right? The challenge to classical logic will have to be shown that even though features of classical logic and theories have been rejected, you can still get by. In particular, you have to show that by going modal, you do not lose great chunks of the modern mathematical megalopolis. So he thinks that you have to show this. It's very precise, and it's imprecise, and it's compelling. What is a great chunk? Once upon a time, I think practitioners in this area thought that maybe a great chunk might mean all of classical mathematics. That every single theorem of classical mathematics might still be derivable in paraconsistently acceptable terms. And Priest says, not talking about exactly this, but Priest says, look, the program of paraconsistent logic was never meant to be revisionist in the way that, say, Browerian intuitionistic logic was, where Brouwer said, the stuff you guys are doing that you should stop doing. And there are paraconsistent logicians who don't think that. Routley in ultralogic is definitely calling for revisions. He talks about classical mathematics like it is a fad that will pass. He says, insofar as mathematics relies on valid arguments, its proper formalization will not be in terms of classical logic. It strikes him as an almost trivial point that alternative formalizations using relevant systems can undoubtedly be devised.
Yeah, but that's not to say that the results are false a la Brown.
That's true. No, no, all right, so he's saying they have to be recaptured appropriately.
Yeah.
It's not to say that...
I mean, he's not expressing a revisionist thought there.
Well, what do we make of this, right? So he says, recovering the bulk of intuitive mathematics, which is not classical, except insofar as recent classical logic reconstructions have pushed it in that direction. Right, so recovering mathematics that way is one thing. So what does he mean there, if not that the recent reconstructions of classical logic have incorrectly construed mathematics as classical?
I think that just means that people have tried to sort of prove all these things classically. And he'd like an ultra-modern proof.
Yep. Okay, so he's, I think, open to the idea of the theorem for theorem recapture. He says, we can do everything you can do, just better and more. So, so it's not revisionist in the sense of Brouwer of those things are theorems and they just definitely shouldn't be. But it's starting again without assuming classical logic.
Absolutely.
Okay.
But still assuming that they're theorems, even though the arguments aren't good?
Well, that's the tricky thing, right? So,
yeah, it seems to me it's a bad program.
well, it's not assuming that they're theorems. It's saying these, I don't know, just hold it's a bad program till the end. What is ultramodal adequacy? That's the question. Right? So there's two bits of ultramodal adequacy. One is the one that has occupied the vast majority of logicians' interest, which is what John P. Burgess unsympathetically calls dialethic recovery, which is showing that there are classical models of inconsistent theory. This is a fully classical mathematical project where you just do classical model theory and show that there's kind of like you can prove that it's Euclidean models of non-Euclidean geometry to show that these inconsistent theories are inconsistent but non-trivial. This is important work. Brady, 1978 proof that naive set theory is probably non-trivial, is really important. So that much has been shown to be up to classical building code. I think what's more interesting is what does this theory actually do once one is reassured? So fast forwarding into the mid-90s, there was this interest in relevant arithmetic, some kind of ultramodal arithmetic. Could relevant logic, theorem for theorem, recapture piano arithmetic? It was shown in 1992 by Friedman and Meyer that it cannot. There are theorems of piano arithmetic that cannot be proved by R, and R is way stronger than anything Routley is talking about. So it will not be able to do that. Ultramodal arithmetic will not vindicate full classical piano arithmetic. So the answer to, well, so which classical theorems are true or provable for the paraconsistent dialectician will have to be some version of not all of them. So I think anyone interested in this program has to take seriously the idea of giving up the full theorem for theorem classical recapture. It's not going to happen, and it probably shouldn't. Because this is a radical, it sounds like a radical program, and I think it is. So looking ahead for ultramodal mathematics, and now we're up to ultralogic 2.0, the apt metaphor, I think, is not recapture, it's rehabilitation. What can we grow on this land? We don't want to just grow back the same exact forest that we just burned down. That would be a really weird project. Right? So what can we grow? I think this will depend on what Routley says is a further stage in the dialectical process, namely the dialectical assent to or incorporation of the meta language. So this classical project was we start with classical logic and construct inside of it a model of our inconsistent theories. And that's been done, and that's interesting. But the progress to be made is to go the other way and start from the outside with a fully paraconsistent ultramodal language and see what one gets. So there were two stages to this program. The first one, only the object language is taken to be dialethic. As Routley says, it's to keep one's feet on the ground. And that's reasonable. Ultralogic 2.0 will involve a full assent to a dialectical meta-language, which presumes, I guess, your feet must leave the ground. And he says, look, I think this should be done. It's just, at this point in 1977, it will be to venture onto more slippery terrain than I'm willing to do here. He says, don't worry, further defense can always be supplied. And if one looks at RLR1, this projected table of contents for RLR2, a book called RLR2 appeared, which has some good stuff in it, but it's not the book that's projected in volume 1. The last chapter projected for RLR2 is called Throwing Away the Classical Ladder, and it includes such chapters as Relevant Logic Semantics, Done Relevantly, Dispensing with a Classical Type Metalogic, Chapter 7, Meeting Earlier Conditions of Adequacy, such as those concerning recovery, and 10, Relevant Logic as Universal. So Ross Brady has he has some boxes with some stuff in it, and I asked Ross, is there anything along these lines? And the answer, he says, is no. So this was just a projection, but that's where Routley Sylvan saw this going. And there have been some steps in that second direction, but it is safe to say, and here's Daniel Nolan in 2018, it is safe to say that this manifesto was not widely taken up. And indeed, so this is a very minor popularity contest point, but it still counts for something. And indeed, the wider relevant logic tradition is on the fringe of work on logic in philosophy departments as a whole these days. I think that's in part because, as any of you who have ever tried to use relevant arrows to do any mathematics, they're super hard to use. The absolute sufficiency implication connective is designed to reason in absolute generality and survive even if it is the only object in the universe, which means it's super strong. So it's useful when there's no background information, but it's really badly suited to mundane kinds of reasoning when there's a lot of background information, like if I order the spaghetti, I'll probably be too full, right? That's not an absolute sufficiency implication that can survive in ultramodal space. That involves a lot of extra stuff. So trying to use this arrow for things like that don't work. A fair amount of flexibility is required when reasoning. And these arrows, which are designed to survive the harshest possible conditions, are meant not to be flexible. So I think one way forward here is to say, look, the absolute sufficiency conditional is super good and useful for this universal program. It shouldn't necessarily be the only conditional. It's allowed to have more than one conditional. Many conditionals make light work. Sometimes if-then means one thing, and sometimes if-then means another, and that's OK. So I'll just float the suggestion along with the relevant DKQ that I've been entertaining. Another very nice conditional is from affine light linear logic. It's the BCK conditional. It involves what Andrew was calling the bad guy, right? It has weakening. It has permutation. It's super flexible. And that's good, too. So if you have two conditionals on hand, that can do good work. And both of them have been shown to be compatible with naive comprehension, although not shown to be compatible with naive comprehension together, so that's something. But perhaps we could have them together. So the BCK sort of arrow will weaken, and that can be useful for weakening contexts. And we have this super strong arrow which contraposes when contraposition is called for. And that gives us a logic that I've been calling sub-DKQ. That's just a thought. So ways forward. So I think this program, well, if not simply doing everything that classical mathematics can do, only better, then what? I think it's been shown that it can't exactly do that. But the basic sentiment, I think, is already there. Actually, it is to do everything that classical mathematics has done after all. And what is that? Namely, be some kind of self-affirming independent theory which supports its own meta-theory and becomes self-standing. So orthodox pure mathematics, I want to say, holds itself to no other standard than the models and methods endorsed by orthodox pure mathematics. If you want a different kind of program, then you need results and standards and methods that are appropriate to that program. It's crazy to think, let's do something radically different, but also try to adhere to all the old rules. Right? That's not a new program. That's just a recipe for getting detention. So we have yet to see if the ultramodal program can really do that by fully ascending to the meta theory, which may be very different than we have come to expect in our classical training. And it's bound to be different, and that was the idea. So we have yet to see if it can do this, only better and more. I'll skip the example. I thought you can do fun stuff with points. All right, conclusion. When, 15 minutes for me talking or 15 minutes for the whole session? Oh, well, you want to see the thing about points? All right. All right. So what could be, as opposed to just trying to sort of mimic classical logic except sort of harder and weirder, what could we do? So let's just think about a geometric point, right, which Euclid famously says is that which has no parts. So suppose you want to come up with a theory of points, extensionless things that somehow take up space. So if you wanted to formalize a point is that which has no parts, you might, if you were doing an exercise in first-order logic, say, oh, well, it's sort of a conditional. A point is that which has only itself as a part. Or alpha is a point if any part of alpha is alpha. So if x is this ordering relation is meant to be the parthood relation. So for any x, if x is part of alpha, then x equals alpha. That would be a way of formalizing the Euclidean sort of thought. But we've got this ultramodal arrow around which can handle all sorts of counter possibles in the antecedent and even take them seriously. So what if we thought another classically equivalent way to put this would be a point is that which all of its proper parts are identical to it. So if alpha is a point, if and only if any proper part of alpha just is alpha. That's classically equivalent to the classical definition that I showed you on the last page, but here it means something different. It means that it's, at least within the space of possibility, there could be proper parts of an extensionless point. They're all alpha. That'll just mean that alpha is kind of a proper part of himself, which is what you should expect from a point. Or even more dramatically, a point is that which all of its proper parts have the point itself as a proper part. So any proper part of alpha has alpha as a proper part of it, which if you had anti-symmetry of the ordering relation would still give you back the classical definition. It's classically equivalent to the classical thing, but this would be totally different if you were investigating that. That would have all sorts of interesting structure. So I think a thing to do here, not the only thing to do, but a thing to do is take some of the space that kind of classical conditionals open up as unexplored regions of structure that have not been looked at and could be looked at. You should do that. Okay. Right. It's sort of, it creates opportunities. So there are opportunities here for new results, not just trying to classically imitate the classical results. All right. So when Routley wrote, ultralogic as universal was a question, and it is still a question. And it ends not with a stomp, but with a challenge. Join the program or beat it, he says. And people don't talk like that anymore. And I think it's a good thing people don't talk like that anymore. We live in the age of logical pluralism, where everybody can investigate whatever kind of algebra they cook up and call logic. And that is good. And it is nice, that I can get up and give talks like this, not just amongst friendly audiences, but even amongst less friendly audiences. And they don't throw things, and they just say, that's very interesting, let's leave. And that's good. And I'm glad we live in a world where we respect each other. But philosophers continue to fiddle, and the world continues to burn. And the title is not ultralogic as one logic amongst many. And it is not ultralogic as aesthetically very nice. And it is not ultralogic as a fun and challenging game to play with friends. I talk to a lot of logicians and I say, why are you doing this? And they say, it's kind of fun and challenging and I can do it with friends. And that's good and they prove stuff and it's fine. But that's not the title. And there's a reason that's not the title. The title is a question, but it is also an optimistic aspiration that ultralogic, some logic out there, I don't know which one, probably not the weak relevant logic DKQ, probably not even that one with a BCK conditional stapled onto it, but some logic out there is universal. It's the key that opens all the locks and resolves all the paradoxes and supports the expression of everything that can be expressed. Maybe it even proves everything that is true. There is at least one true logic. Well, whether or not there is, or whether there ever will be such a logic, he asks us and urges us to keep asking the question so that we can think better about our lives and so that one day maybe the world can cease to burn. Thank you.
Can you go back to, it was sort of at the end where you were talking about, which I found very interesting, that classical mathematics, you said something about them taking the standard to apply. Can you go to where you had it?
It was in bold.
Yeah,
I know.
bold, yeah.
I was thinking
Which caught my
I was thinking this morning that I shouldn't say this. Yep.
Mathematics holds itself in the understanding of truth and the models and methods and whatever.
I did say pure mathematics when I said it out loud.
Fine.
Okay.
Yeah, but it sounds like you think that orthodox mathematics thereby thinks that that they can collapse the meta language of their theories and all this. But of course, in no way does orthodox mathematics take itself to have notions of proof that are in the various consistent theories and all that, at least not ones that they would say matches what they're doing. So, I mean, it seems to me that orthodox mathematics does hold that classical logic, which is just the relation that governs the logical vocabulary, not necessarily the mathematical vocabulary, that's going to be the same in the meta language and in all of their object languages. But what Roundley seems to be after is much more than that. That distinction has to somehow collapse if you're being true to this goal. And I guess I'm trying to understand what you are taking from this bold-faced claim and how it contrasts with the other one.
Yep, thank you. So I don't mean by this claim that orthodox mathematicians think that the object language should collapse into the meta language. I mean, they'll explicitly tell you that they don't mean that. I mean more a general sociological claim, like mathematics, orthodox mathematics is a set of practices and techniques agreed upon by a culture of people that all lines up with itself relatively nicely. So you have one area like model theory and one area like proof theory and mathematical areas that like classical topology, and it all lines up really well and is based on similar kinds of techniques and ideologies. And I'm suggesting that alternative approaches should adopt their own techniques and approaches as opposed to just trying to do exactly the same thing as orthodox mathematics. So it's not to say, so a couple things, right? I'm not even saying that Routledge thinks that the meta language and the object language should necessarily be collapsed. He's saying that to make progress on this, we need to ascend to a dialectical meta language, which isn't even necessarily to say it's the same language. I would say that they should be collapsed, but that's a further claim that I wouldn't want to saddle him with. So.
Yeah, there's something I'm not getting, but I'm not able to make it clearer than what I've done. So it's,
Yeah, I like that a lot. Even hearing it a second time.
Yep. Thank you for contributing to the book.
Well, you're sure. It's about the Meyer result, which was, I think, about 1988 rather than 92.
It was published in 92.
Yeah, it was published in 92. But at any rate, about that. So Meyer still held out hope for R sharp and a half after that. And he gave some talks while I was in Japan on this. And he still held out hopes that there were just that I mean, just taking the piano axioms and turning them into the relevant system didn't work. That's true. But doing a bit more than that, adding something else might have worked. And I don't think it's been shown that that can't work. That can't capture. I mean, obviously you can add enough to get it, but you know, but the question is, you know, could you do something that's relevantly acceptable? Could you add axioms that are relevant and acceptable? I still think that that's actually a pretty interesting project.
Yep.
And about the stuff about why capture classical piano arithmetic, it wasn't to capture the classical system, you're right about that, but it was to capture this sort of pre-logical system of arithmetic that people were using beforehand. And in one of those talks in Japan, he started off by saying, look, he wants to look at arithmetic.
This is Meyer?
Yeah, Meyer, rather than Sullivan. He wanted to look at, but I think Sullivan was thinking the same thing, that he wanted to look at arithmetic because it was something that was, and instead of something like set theory, because set theory grew up out of classical logic, but arithmetic was something that could be thought of as untainted by classical logic. It just happens that classical piano arithmetic captures those theorems, and he wanted to capture them too. And I think that sort of classical recapture was, or orthodox recapture, which is the capturing, you know, Euclid stuff. That's really what they wanted, rather than recapturing stuff that had happened since the advent of classical logic. I think that both of them wanted that.
Yep, thanks for the question. So just to remind me, R sharp and a half is adding the omega rule?
Oh, no, that's R sharp sharp.
Oh.
R sharp, sorry, you can't make these distinctions. Come on. Get up and play.
It's okay.
Yeah, that's R sharp and a half is a system we don't know what it has in it.
Oh.
It's somewhere between R sharp and R sharp and a sharp sharp. That's why it's R sharp and a half.
So it's something weaker than adding the full omega rule, but stronger than...
Yeah, because you know if you add the omega rule, you get all the piano arithmetic with the omega rule, right? So at that point.
Mm-hmm.
But R sharp and a half is supposed to add more sort of finitely expressible axioms or rules, other than the camera rule, which would of course give it to you what isn't acceptable.
So I'll just start with the last thing you were saying. So this notion of something like pre-formalized or pre-logical mathematics and wanting to capture that, I think that's exactly right? That that this thing called mathematics that's a practice that's out there in the wild, and logicians come along and provide various models of it, maybe. Mm-hmm. And that's what he's talking about here. So it's not just trying to take, but then again, the most worked out version is the classical PA version, so that's a natural thing to look at. But that is what they're talking about doing. And it's not clear then what the success criteria necessarily is. Like, is it getting all of Euclid, or is it getting all of Euler, or something like that? What I want to say to the first bit about, say, Meyer, is I think there are different projects, even within the Australasian relevant tradition. Again, John P. Burgess once wrote something like, he said that Anderson-Belknapianism is so different from Routleyanism that they shouldn't even be considered the same sort of thing. So there's this one project which is using, say, a strong relevant logic like R, which Mike has done some good stuff on for like Robinson arithmetic, that's using a stronger logic and is much more amenable to orthodox kinds of approaches. And then there's this sort of 1977 Routley version, which is circulated just in TypeScript, which is talking about using a much weaker logic that can use, say, full naive comprehension and do a really more alternative sort of program. And I think those are different kinds of projects. So I think there's, as you say, the case is not closed on something stronger than R sharp, but maybe not R sharp sharp. Greg has done some stuff even within the last 20 years on further investigations of relevant arithmetic. So that would be interesting to find out. But given that R is already way too strong for ultramodal logic, right? R does not survive in every possible situation. So it's just a different project. And like I said at the end, it's good that different people can work on different projects, but they're different projects.
Any other questions?
I have a question about Friedman-Meyer as well, which is the greatest slide.
Yeah. Oh, there it is.
Failure. So the last time I saw you, like ages ago,
Yeah.
I remember talking to you about Friedman and Meyer, and
Yeah, don't move on.
well, no, but what you have, which is why I'm asking the question, which is you'd expressed a lot of skepticism about the result. And my recollection is that you had been skeptical because it's proved in a sort of classical meta theory that this counter model is in fact a counter model. And a lot has happened presumably in 7 years, but you seem to be interpreting it much more pessimistically now. And I'm just wondering if anything has changed. Did you satisfy yourself that it was indeed a counter model, or what's changed in 7 years?
No, okay. So thank you for calling attention to the talk that I gave in Rio a while ago. Yes, so the Friedman and Meyer result is it's published in the Journal of Symbolic Logic. It's a piece of classical mathematics. It shows that the ring of complex numbers is a model of relevant arithmetic. It does so using definitely classical methods, right? So it uses disjunctive syllogism and assumptions about the consistency of set theory in essential places. So at the time I was thinking, and I guess I'm still open to the thought, if one were doing fully dialethic paraconsistent model theory and wanted to show, is there whatever the ring of complex numbers would end up being when you constructed it that way, would that thing be a model of relevant arithmetic? That's an open question. It certainly wouldn't be using the Friedman and Meyer result. So I think that still holds. I guess what I mean by failure is that if you're holding this project to something like classical mathematics as a standard, then it falls short of that because by the lights of classical mathematics, it has failed. So that's kind of what I'm suggesting. Ultralogic 1.0, insofar as it's trying to do everything you can do, only better and more in the most naive sort of way, it can't do that. Maybe the version where you say, all right, let's see what the models of relevant arithmetic look like using ultramodal model theory, which might be very different than what we think of as model theory, then I don't know. And so the jury would still be out on that. So I haven't changed my mind. I'm just being more conservative.
Thanks.
Sure.
I wondered if you could say a little bit more about the move from universality to total sufficiency.
That is this, yeah.
And like applying the test of total sufficiency for logic. So there was a lot of discussion about material conditional when that part was going on, and that made me wonder, like, is it a test that every logical expression is supposed to pass?
Yeah.
Or is it more about a test for the entanglement relation?
Yeah, this is a bit of a slide. So I put it in bold with dashes to make it seem like it's connected. Right. So we're concerned with universality, and that just naturally leads to a desire for absolute sufficiency because we want the maximally general logic that applies in all situations, and that should be the one that maintains the connection between antecedent and consequent in the tightest possible way. But as Ed points out in his chapter about this paper, also, really to think that that pushes you toward anything like a relevant conditional, you already have to have some relevance intuitions. So if somebody were strongly not inclined toward relevance, they might say, this absolute sufficiency thing, that sounds great, but if B is a theorem, then anything is absolutely sufficient for a theorem because it's a theorem. So just invoking absolute sufficiency doesn't actually land you on relevance unless one is already somewhat predisposed toward it. So that's why I was kind of couching this as an inductive or abductive sort of argument where it's saying, you know, all of these things would work well together. Let's see what it can do, as opposed to saying, this just naturally falls out of, it naturally falls out of universality if you're hanging around with relevance logicians and it ends up seeming natural to you. But I think you're right that it's not a watertight bit of the argument, if that's what you were asking.
Yeah, that's helpful.
Yeah.
Thanks, Zach. Brilliant talk as ever. Just on a historical note, Richard gave me a TypeScript of algebra logic in 76 when I met him at the AL conference where I read Logic Paradox. And I remember reading it on the flight back from Canberra to Perth. And I was just blown away by it. I mean, I was playing with, you know, Gödel's theorem, paradox, self-reference. Richard had a vision that I did not have, just because he saw it everywhere. Okay, I was sold on the project, and it certainly did inform a lot of the work that went on in Canberra with the Canberra Logic Group several years after that. And I think you've done an excellent job of explaining what was in it. I think you're doing right. And more substance is what remains of the project, you know, so many years on.
40 years.
Yeah. Okay, so one thing I think is definitely gone is this sufficiency condition. Just because Richard wasn't thinking about intentional situations in those days. But if you think about the situation as it's believed to be by someone or feared to be by someone, this can be almost entirely anarchic.
Yeah.
Okay, so you're never going to have a conditional which preserves holding in those things.
Yeah.
Okay, so I think the search for a universal condition, universally sufficient condition, is just gone. Okay, that doesn't show that the project is gone. That just shows that basically not a sufficiency condition has gone. Another thought is that, as you've explained, Richard saw, in some sense, the recapture of classical mathematics as part of the program, in some sense. Okay, and a lot of work was put into that in the Canberra group, and we failed until you arrived on the scene.
Yeah.
But I kind of suspect that would not be part of Richard's project, because mathematics has gone a long way since 1970, partly because of paraconsistent logic. And we now know that there's classical mathematics and there's intuitionist mathematics, which wasn't taken very seriously in the 70s. There's paraconsistent mathematics. And I think nowadays a very natural view is mathematical pluralism. And I rather suspect that Richard would have become a mathematical pluralist. He was certainly moving towards pluralism towards the end of his life because of the book on pluralism and metaphysics.
And transcendental metaphysics.
Transcendental metaphysics, which is all about pluralism. So I think that would have been his response about mathematics. What about logic? So this is more the crucial question. Would he have still believed in one true logic? Okay. Of course, logical pluralism was not on the agenda in those days either. So had Richard lived till now, which he could have done, I mean, then he'd been very old, but not that old. Well, he'd been nearly 90. Would he have said that there is one true logic? I kind of suspect not, because I kind of suspect the move towards pluralism would have made him sympathetic towards logical pluralism. So in that sense, I think algebra logic would have gone. But that doesn't mean that something very valuable in the program would have survived. It is, hey, why are you so bloody well obsessed with classical logic? We've got lots of non-classical logics and lots of things we can do much better. And I don't think he would ever have changed his mind about that.
Okay. Yep. Thanks. So you would certainly know better than I what Sylvan might think if he were here now. But I think you're definitely right. The last stuff he's writing He's not just a pluralist, he's a pluralist about the actual world. He thinks there's more than one actual world, which is kind of an arresting claim. So I think the thought that he would be have drifted in those directions are definitely right. So that's partly why I talk about Routley, because I'm talking about the thought circa 1977 as opposed to the artist no longer owns the work once it's released to the public. So I think you're definitely right. That's where he would have gone. Doesn't necessarily answer the question of what becomes of the ultra logic project. He does address in various places in the ultra logic essay things about logical pluralism. He calls it the local logic option. He says, what if somebody said there's an appropriate logic for this region and an appropriate logic for that region, and why not that? And he says, I get worried about what happens at the boundaries between these regions. So he does sort of think about that.
That's a fair enough reaction to logical pluralism in general.
Yeah.
I don't know what his view would have been circa 2010. I suspect he would have gone pluralist about most things, but that's only conjecture.
Yeah.
But I think the really important thing is, so we wouldn't have subscribed to the whole archaeological program. That's right, we all learn from what happens in our research, and research programs develop. But I think that, the iconoclastic Richard would have survived. Okay, he'd have taken the claims that you must be stuck with classical logic or something equally Procrustean. His rejection of that would have survived, and he would undoubtedly, I think, said that we can do much better on many of these projects with non-classical logics. I'm sure that would have survived.
Yep. And it's not even clear to me that the author of the 1977 thing is the full-blown logical monist that maybe I'm construing him as. It's not totally obvious. Just on one other point you made about intentionality or hyper, that's all right, that you could have these logically anarchic kind of situations that don't seem to be governed by any logic. He also does address that in the ultra-logic essay. He says, imagine we met a tribe of Hegelians, and and they believed things like A and A arrow B, but they somehow failed to believe that B. So he kind of distinguishes between the internal logic of a world which may not obey his logic but he said ultra logic would still hold over the world. So we would still say that in that world B, even though the people who live there don't say that B. He doesn't elaborate that any further, and it is a sticky question about what to say about if you're really introducing lots of badly behaved points into your modal space. Surely there is no logic that internally governs all of those.
That's for sure.
Yeah.
Okay. But if you think that you're really wanting what you really want a conditional, which is going to preserve holding over every space, however badly behaved, you're going to get essentially nothing.
I think that's true.
You get an identity.
No, you don't even get identity.
Well, I don't mean that well, it depends on if you're evaluating an arrow at the world, sure that breaks. But if you're going like from A turnstile, you're not going to break that by.
No.
Okay.
No, look, if you have enough worlds, then you have this trivial world like the Tau world, and then, in some sense, everything is possible. And in some sense, if everything is possible, there shouldn't be any theorems. I'll just let that hang. Yeah. Mike?
Thanks. That was a wonderful lecture. I really appreciated the way in which you portrayed Richard's, I'll call them ambitious views. Bob Meyer once claimed, with respect to their Routley-Meyer semantics, as it's referred to in the original version that Richard had written, Richard claimed the waterfront. And I think that's a good saying to portray of Richard's philosophical and logical ambitions. And I knew both Bob and Richard very well and spent time down under, as we say here. And I really liked your characterization of North America as liking the bigger, larger systems, R and so on, and the Australasia liking the weaker systems.
And I agree with much of what Graham said in large, but also about what he said about your work. I think it's been the best at trying to get a kind of relevant, very consistent mathematics. I wanted to say that, what did I want to say? Something.
That was very nice. I'm very happy with that.
Yeah, stop there.
I don't want to interfere with people's dinner, so I'm tempted to. But I wanted to say that your characterization of my view, liking R and not the weaker systems, is absolutely right. And as soon as it was Richard, Bob, and I discovered that the Curry paradox got in the way of a truly naive relevant set theory, right? That, and people like Ross, Brady, and so on began to experiment with much weaker systems and so on, and I gave up, frankly. And I just wanted to make that clear. My interest more recently has been not in trying to get some relevant foundation of mathematics, whatever that would be, something profound, but on much probably more important issues, which has to do with inconsistency as you find it on the internet, or inconsistency as you find it in the middle of cloning in cloud computing or something like that. And for that, I think the stronger systems are more useful, and I just wanted to make that point and kind of reinforce what you were saying about the distinction between the two kinds of approaches. I thought this was a wonderful talk. Thank you.
Sure, thanks. I would just add, with respect to the Curry paradox in that 1979 paper that ends with the sentence, "Naive set theory is hopeless,"
Yes.
That the situation since then has gotten much worse. Right. That Curry paradox is not there are just worse and worse ones all the time.
We even had a different version of it too that made things worse even back
Yeah.
then.
So that it has, to persist with this type of stuff, one must be undeterred by apparently hopeless results, which is I kept saying optimistic, but I would say just that it's really good that now look, this event is being held in a place that traditionally, historically, didn't have connections to this program, and now this stuff is blossoming all over the world with different people interested in it, and the only way it's going to make progress is by more people getting involved and new generations of people expending their youths and energies to try to do this sort of stuff. So it's very nice to see that interest remains, and that's the way forward.
Yeah, I agree.
It's the children.
So I have a kind of general question, but I'll try and fill it in a little bit. So I'm really sort of wondering, by lights of some of these really ambitious programs, why recapturing classical mathematics in particular is such an important thing. I think of it for a couple of different reasons. So one, I think sort of picking up on what Graham mentioned in passing, like some ways of looking at it, it's sort of like botany. Right, so we're in North America and we're in Europe, and we're studying some creatures that are in North America and Europe, and it turns out in the Galapagos there are other creatures. And there's no sense in which you need to classically recapture the Galapagos turtles. Right, just more stuff.
Right. So that's the pluralism that Graham was
Yeah, the other possibility, is, it doesn't have to be just like botany. It could be that we have really terrible theories based on only looking at the creatures in one part of the world, and once we look at more of them, we scrap it entirely, so I don't have to be purely pluralist. But the starting out with the goal that this is what was going on over there, and at that moment, the baseline for my making progress is recapturing that.
Yeah.
Feels like, I'm never totally sure why that's where we want to start.
Great. So I think partly the question, answer to why that's where people start is when you start presenting non-classical logics to audiences, the first thing somebody says is like, but what happens to classical mathematics? And one's inclination is to say, don't worry. That's what you'd like to be able to say. just for like social reasons. But yeah, so suppose you're not worried about that, and you're thinking the pluralistic idea is why see these things as rivalrous? There's just more objects. That's one way to go. I think you could go that way. The motivation for not going that way, which you could take or leave, I guess, is to say, well, suppose you think that logic is meant to be the maximally general, content-neutral arbiter of which inferences are valid and which are invalid. And you think that inconsistent objects provide a counterexample to inferences that require consistency, then since logic is the thing that should be content neutral and topic neutral, it should apply everywhere. So theories that are cooked up using invalid logic are not acceptable. I mean, if that's really what one thinks logic is for. So that would be, it's not a motivation for classical recapture, it's a motivation for going back to Euclid and saying we better start again. So that's not classical recapture, that's what I'm calling sort of rehabilitation of the intuitive kind of mathematics. So, but that is obviously the super fundamentalist version, and my experience is that nobody is attracted to that except for me. Yeah, so I think there's a lot of legitimate ways to go here, and they could all contribute to this project in useful ways.
Any other apart from Graham have a question?
It's not really a question, but it sort of picks up on Zach's comment on the new generation. And I wanted to say something about Zach himself, because Zach came to work with me in Melbourne. When was it, Zach?
2004.
Okay. And he'd been reading Beyond the Limits of Thought, and he liked the closure schema, and he said, oh, I want to work on this stuff, I'd like to free will determinism and these things. Oh, that's fine, right? Go away, think about it, again. He went away and he came back a few weeks later and said, change my mind. And he said, I've been reading this paraconsistent relevant set theory stuff, and I want to really prove all these results of classical set theory in using a relevant, naive set theory. And I said, Zach, don't do that. No, this was one of the things we've been working on in Canberra in the 70s and 80s. And we'd all had a go. I mean, Richard, Bob, John Slaney, Ross Brady, myself, Chris Mompson, and it didn't work. And I wanted him to get his doctorate. So I said, don't do it, Zach.
It was good advice.
And he said, I'm going to do it. I said, oh, okay, good luck. Okay, and he did it. Okay. And this was, the most fantastic advance on the subject since we've all given up. And what Zach did was this. We've been trying to reconstruct classical proofs relevantly, and that did not work. What Zach did was find whole new proofs. Okay, now the proof techniques are kind of interesting, and you might have worries about them, but it was this new insight, which none of us have had before, that to do this, you need some completely new thinking, okay? And the program is not dead. I mean, it's entirely possible that new thinking will push it forward again. And I might add that Zach has a manuscript of a book which has a number of new ideas about how to do this. And I'm sure that there's lots more where they come from. So I can only endorse his words, that, there's lots of work for the new generation of logicians still in the program.
Thank you.
Any more questions? Well, thank you very much, Zach.